Well, today I will be discussing about a transportation problem. And the transportation problem is a part of the linear programming problem. And it is related with the transportation of goods from a factory to the warehouses, as an example, from particular place to a destination, and the minimization of cost. So, so this is the transportation problem, and there are some steps by using you can solve a transportation problem. And with an example, I try to clarify the the transportation problem, and it will be very helpful for you for understanding a transportation problem and how it can be solved. So now look at this problem. Solve the transportation problem and obtain the optimal solution. So obtain the optimal solution. At first, you have to find out the initial feasible solution. And after finding the initial feasible solution, you have to check whether your solutions are optimal or not. If your solutions are optimal, then you can easily find the transportation cost. So before before going into the steps of solving the transportation problem, at first you have to understand this table. So this S1, S2, S3 are the factories for producing goods, and D1, D2, D3 are the warehouses where the goods actually will be shipped. So this is the S1 has the 20 capacity, and S2 has the 30 capacity, S3 is the 80 capacity. And demand from the warehouse 1, that is D1, is 40, and demand from warehouse D2 is 30, demand from warehouse D3 is 60. And these values 4, 6, 6, 8, 2, 4, 2, 6, 1, actually the values of you can have the values of costs. Now you can understand that whether the transportation problem is balanced or not. At first, this is the first step. You have to check whether the transportation problem is balanced or not. Now if you see the supplies, that is 20, 30, 80, if you add these values, then you have 130. And if you add the demands 40, 30, 60, then it will be also 130. So demand equal to supply. So it is a balanced problem. Now we solve this problem by using the northwest corner rule. So northwest corner rule, these are the east, north, south, and west. So this portion is the northwest corner. Okay, so this is the northwest corner, this is the tape box and northwest corner, and the demand is here, suppose 20, and demand is 20. So sorry, supply is 20. So supply will be placed here, and it is used, and so here it is 20. 40 minus 20 is equal to 20. As this row is exhausted, so I do not consider this row. Now there is this box is there. Okay, so this is the northwest corner, and here is the 30, demand is 30, and supply is 30, and demand is 20. So 20 is here, 20 finish, and 10. 30 minus 20 will 10. Now this column has no use. Now 2, 4, 6, 1, 2, and this is the northwest corner. So 30, 20, 10, 20, 10 is there, and 10 is totally exhausted, and 30 minus 1, 20. Okay, so this row has no use. Now this 6 and 1 and 20, 60 is 80, So I place 20 here and 60 here. Okay, so 20 is used, 60 is used, 80 is exhausted. Okay, so all the supply and demand has been used. Now I draw the table by putting the allocation very clearly. So this is 20, this is 20, this is 10, this is 20, this is 60. Okay, so these are the allocation 1, 2, 3, 4, 5, and solutions are 5, and you know the m plus n minus 1 equal to m is 3, number of rows, and number of column is 3 plus 3 minus 1 equal to 5. So this 5 is equal to the number of solutions. So there is no degeneracy problem. So non-degeneracy, it has non-degeneracy. So our solution is non-degenerate and it is independent. Why it is independent? If we start from here, then we are here, this way, just considering the allocated box. So we never come back here on the basis of the allocated box. So this is independent. So our solution is independent and non-degenerate. And so that the initial feasible solution is equal to 4, 20 plus 8, 20 plus 2, 20 to 10 plus 6, 20 plus 1, 60. Okay, 80 plus 160 plus 20 plus 20 plus 60. So now 0, 6, 8, 10, 16, 6, 1, 2, 3. 3. Okay. So 360 is the answer. 360 is the answer. Initial feasible solution. That is the transportation cost. Initial feasible solution. Now we check whether this solution that is optimal and independent, this initial feasible solution is optimal or not. Okay. So how this can be checked? Now we can check in such a way that we have to find out the UI. We have to find out UI, Vz and del Iz. And you know UI equal to Ciz minus Vz, and Vz equal to Ciz minus UI, and del Iz is equal to Ciz minus UI plus Vz. So by using these formulas, we are going to find out the values of U1, U2, U3, V1, V2, V3. Okay. So ui means u1 and Cij. If you like to find out the u1, then you should follow this formula, and if you like to find out the vj or v1 to 3, then you should follow this formula, and if you like to find out the del ij, that is the empty cells, then you should follow this formula. Okay, so now for finding out the u1 or ui or vj, we have to consider the maximum allocated row or column. The maximum allocated row, this is 1, this is 2, this second row has 2 allocated, third row has 2 allocated, and first row has 2 allocated, and first column and second column has 2 allocated, third column is 1 allocated box. So you can have the maximum allocated is 2, so you can take any row or any column considering the allocated box 2. Okay, so for now we are considering v1 is equal to 0. We consider v1 equal to 0. The maximum allocation is here, and 4 and 8, 20, 4, 20, 8, 20. So now on the basis of v equal to 0, 4, u1 will be 4 minus 0 as the rule says. So 4 equal to 8 minus 0, so 8. Now 2 minus 8 equal to minus 6, and now so minus 6, this is 6, so 6 minus 6 minus plus 6 plus 6 equal to 12, and 12, 1 minus 12, that is 11. Okay, 1 minus 12 minus 11, okay, because for the formula is Cij minus uj for vj, so Cij equal to 1 and Vij is 12, so 1 minus 12, minus 11. Okay, so in this way we have these values. Okay, ui, u1, u2, u3, v1, v2, v3. Now we use these values for finding out the del ij. Del ij, it is del 1 2, del 1 3, row column 1 3, row 2 column 1 2 1, del row 2 column 2. Sorry, this is the empty cell. These are not the empty cells. So 2 3, 3 1, 1 2 3 4, 1 2 3 4. Okay, so the formula is, you know, the Cij minus ui plus vj. Using this formula, putting this value, this is the 4 minus 4 plus 0, and this 1 3 6 minus 4 plus 0, 2 3 4 minus 8 plus minus 11, and for this equal to 2 minus 12 plus 0. Okay, so this value is 4 minus 4. 4 minus 4. No, here is something wrong. So C1J is 4, and U1 4, and it is V2, it is 6, minus 6. Okay, minus 6. Minus 6 and minus 2. Minus 2 minus 2 plus 2, 6. Equal to 2. Is equal to here 9, 10, 11, 3 plus 3, 7, and here minus 10. Minus 10. Okay. So minus 10 is the minus here. Now we should consider the maximum negative value. The maximum negative value, that is the minus 10 here. The minus 10 negative value. So now the minus 10 is del 3 1. It means here del 3 1 here. So we put x plus x here, and minus x is here, plus x is here, minus x is here. Okay. So now we try to find out the closed path. So if we move in this direction, and then in this direction, then in this direction, then in that, the closed path is here. Okay, closed path is here. So now the minimum between the minus 2x is 20 and 20. So minimum of 20 is the minimum. So we subtract this 20 from the negative negative x and add with the positive x. If we add with this, then it is 10 plus 20 equal to 30, and it will be 20 minus 20 equal to 0, and here it will be 20, and here it will be 20 minus 20 is equal to, it is minus, so 20, here is also 20, so minus is 0. Okay, the 2 is 0. So now we put the values here. So it will be 20 and plus it will be 30, and it will be 30, and it will be 20 minus 20, it will be 0, and it will be 20, and it will be also 0. Okay, so now if I construct a new table, then you can have this table like this. Look, 4, 20, 4, 6, 8, 2, 30, 4, 2, 20, 6, 1, 60. Okay, this 30. So these are the demand D1, D2, and D3, S1, S2, S3. So now we check whether these solutions create the degeneracy problem or not. So here this number of solutions is 1, 2, 3, 4, but you know the n plus n minus 1 is 5. So 5, so 5 and 4. So m plus n minus 1 and number of solution, and this is the number of solutions. Number of solutions is not actually equal. Okay, so the problem of degeneracy is here. How to solve the problem of degeneracy? Now look at this, the cell 8, 6, 4, 6, 4. So these costs, among these costs 8, 6, 4, 6, 4, you have to take the minimum cost, and minimum cost is 4, 4. So you can choose any one and put a very little number, that is epsilon. Now I put epsilon here. So now again we have to check whether the solution is optimal or not. So again the same way we try to find out the optimal solution. So look at this. So you have to find out U1, U2, U3, V1, V2, V3. Now I am writing here U1, U2, U3, V1, V2, V3. So maximum allocation you can have in this row 2, and in this row 1, and along the S1 row there is 2, along the S2 row 1 allocation, along the S3 there is 2 allocation, along the, if you consider column D1, so 2 allocation, and D2 2 allocation, D3 1 allocation. So maximum allocated row or column you should select, as there is a the equal number of rows and column that actually bearing the maximum allocation in this case. So I consider for my convenience, so U1 equal to 0. Okay, now by using the U1 equal to 0, you can easily find the V1. So V1 is 4 minus U1. So 4 minus U1 is the V1. So V1 equal to 4. 4 minus 0, and now you can have also this V1 equal to 0, V1 equal to 4, sorry, V1 equal to 4. Now as V1 equal to 4 and this is 20, this is 2, so you can easily find the U3 because this is the allocated box, and so 2 minus 4 equal to minus 2. Minus 2. Now this is the minus 2 and 1 minus 2, 1 minus minus 2, minus plus, so 1 minus 2 equal to this is 3. V3 equal to 3. Now V2, so this is 0, this is 4 minus 0, V2 equal to 4. Okay, so now this is 4, so 2 minus 4 equal to minus 2. So equal to minus 2, 4 minus 2. So we have U1 equal to 0 and U2 equal to minus 2 and U3 equal to minus 2 and V1 equal to 4 and V2 equal to 4 and V3 equal to 3. So these are the values of Ui and Vj. Now by using this Ui and Vj, you have to find out the del Ij. So del Ij means the empty cells, these are empty cells, del 1 3, and this is del 2 1, this is del 2 3, and this is del 3 2, del 3 2. We have to find out these values. Okay, so Cij is 6, here Cij is 8, here Cij is 4, here Cij is 6. Now minus, and considering this 3, 0 and 3, so 3 equal to 8 minus 8 is there, so 4 plus minus 2, that is 2, 2 and 8, 4 minus 2. Now this is 4 and minus 2 plus 3, minus 2 plus 3 plus 1, so minus 1. We are using the formula, that is Cij equal to del Ij equal to Cij minus Ui plus Vj. Okay, we are following this formula. So now del 32 is 6 minus 4 plus minus 2, 4 plus minus 2 is 2, so 6 minus 2. Now this is the value is 3, value is 6, value is 3, value is 4. So all the del Ij's, that is all the empty cells, now showing the positive values. Now showing the positive values. So we have the optimal solution. Now we have the optimal solution, and as there is optimal solution, so now we check whether the optimal solution, from the optimal solution, the cost of the transportation, cost. So now I moving this. So optimal cost is 4, 20 is allocated, plus 4 into epsilon, plus 2 into 30, plus 2 into 20, plus 1 into 60. So equal to 80 plus 4 epsilon plus 60 plus 40 plus 60. So if you add these values, 8, 6, 4, 100, 180, 240 plus 4 epsilon. Okay, so approximately we can have 240, because epsilon is very minimum, very little value. So this is the transportation problem, and in this way we can solve the transportation problem. And the steps I have mentioned, at first you have to check whether the transportation problem is balanced or not. If it is balanced, then you have to follow the any rule. Here we have used the northwest corner and Vogel approximation method you can also use. And after using this, you can have the initial solution, feasible solution. Now we check by using the initial feasible solution whether it has a degeneracy problem or not, and whether it is independent or not. After checking all this, you have to find out whether it is optimal or not. And I have mentioned all the steps one by one for your clear understanding. So I hope you have a better understanding after this lecture and regarding the transportation. So thank you for enjoying this.